Hey everybody, welcome back. Thanks for watching. Got a cool problem today, but first we need to review some pieces that we're going to need to solve the problem. So first we have the cosine of the sum of angles. So the cosine of x plus y is exactly the cosine of x times the cosine of y minus the sine of x times the sine of y. And then we need the cosine of the difference of angles formula. So the cosine of x minus y is the cosine of x times the cosine of y plus the sine of x times the sine of y. So with that said, let's check out this problem. So for today, we've got the cosine of a plus the cosine of b is equal to 2 times the cosine of a plus b over 2 times the cosine of a minus b over 2. Okay, so how do we tackle this? So I'm going to work with the left side and show that it's equal to the right side. And so let's take a look. So we've got the cosine of A plus the cosine of B. And here's where we get to be a little clever. So sort of keeping my eye on the prize, I know that I want to transition to having angles that look like this. I mean, right now I just have angles that look like A and B. I want angles that look like A plus B over 2 and A minus B over 2. So here's what we're going to do. We're going to represent A like this. So for cosine of A, let's call it cosine of A over 2 plus A over 2. I mean, that is A. But to cleverly introduce the B over 2, we're going to use auxiliary terms. That's essentially when we add a useful form of 0. So we're going to add B over 2, but also subtract B over 2. And if you look, I mean, this is still cosine of A, but it's a very, very helpful and useful form of cosine of A. So sort of inspired by this thinking that's going to allow us to transition into angles like this, let's rewrite cosine of B. So cosine of B, I can call that cosine of B over 2 plus B over 2. And then essentially playing the same game, I'm going to add A over 2 and subtract A over 2. Again, there's another useful form of 0 or auxiliary terms, as we like to say. Okay, so let's group these together so our angles start to emerge. So let's rewrite this as the cosine of, let's say, A plus B over 2. So just grouping these together. And then how about plus A minus B over 2? Okay, so similarly, here, we're going to have the cosine of, let's take a look. So A plus B over 2. Okay, so if we're smart about our grouping. And then for the other grouping, we're actually going to factor out a negative. So minus, so I'm looking at these terms. So factor out a minus, so that'll be A minus B once I factor over 2. But notice how nice that is. We have the cosine of the sum of angles, and we also have the cosine of the difference of angles. So let's go ahead and expand each of those. So here, I'm looking here, I'm going to have the cosine of the first angle times the cosine of the second angle minus, right, if I'm using the cosine subformula, that's a minus there. It looks like the sine of the first times the sine of the second. Now initially, you may be kind of nervous that we've introduced some sines, but something nice happens. So with that said, let's go ahead and expand this out. We've got the cosine of the difference of angles. So that's going to be, it looks like the cosine of the first times the cosine of the second plus the sine of the first angle times the sine of the second angle. Look at that, close to the edge there. You can almost hear the Mission Impossible music. Can we do this? There we go. Okay. Whew. Good. So if you take a look here, it looks like we have additive inverses. So these terms will cancel. They're gone. And then what remains are these nice like terms. So one of these plus one of these, it means I've got two of them. So that's 2 times the cosine of a plus b over 2 times the cosine of a minus b over 2. And that's our result. How nice is that? That's a cool little problem. So again, just a reminder, don't forget to subscribe to the channel. A lot more cool trigonometry, calculus, pre-calculus, multivariable calculus, linear algebra on the way, all kinds of cool stuff. Lots of proofs too.